Topic 4.4. We'll be graphing these polynomials, and we'll be finding 4 parts and then graphing. The 4 parts are, first will be the y-intercept. We find the y-intercept by changing all the x's into 0. So we have 0 to the third minus 0 squared minus 9 times 0 plus 9. And 0, 9 is the y-intercept. Next, the x-intercept. We find the x-intercept by setting the equation x cubed minus x squared minus 9x plus 9 equal to 0, and then solving for x. Okay, we're going to solve by factoring, and I'm going to factor out the greatest common factor out of the first two, so we're doing factoring by groups. So x squared times x minus 1, and factoring out a negative 9 here times x minus 1 equals 0. The greatest common factor for these two will be x minus 1, leaving behind the x squared minus 9, set equal to 0. This is the difference of 2 squares, so this can be factored into x plus 3, x minus 3. And now when we solve each one of these binomials, we're going to get x equals 1, x equals negative 3, and x equals positive 3. So these are our x-intercepts. So we have negative 3, 1, and positive 3. Okay, next, the end behavior. The end behavior is all based on the first term. And the first term here is x cubed. So this is a positive coefficient with an odd power. That means that the right side will go up on the endpoint, end behavior, and the left side will go down. Okay. Finally, we're going to use the multiplicity to track through our intercepts. As we go from left to right, we head toward negative 3. We see that negative 3, its factor was to the first power. That means the multiplicity was 1, and we go straight through. Go through the y-intercept, and now we head toward the next intercept, x-intercept, which is 1. And 1 came from here, and the exponent there was 1, so that's multiplicity 1, which means we'll go straight through. Then we head to the last intercept, which is 3. 3 here came from a factor that had an exponent of 1. That means the multiplicity is 1. That means we go straight through. And this is the graph. Number 6. Okay, number 6, let's get the graph ready. And first we'll look for the y-intercept. By setting all our x's equal to 0. This evaluates to 0, so we have a y-intercept of 0, 0. Okay, next we find the x-intercepts by setting the equation equal to x and then solving for x, and we're going to use factoring. So the greatest common factor would be a negative x cubed, and what will remain would be a x positive x squared, a negative x, and a negative 6. This trinomial is a quadratic and can be factored into 2 binomials. So factoring this into 2 binomials, we'll have x times x, and then for the 6, let's make that 3 times 2. The signs have to be different, so we'll make this into a negative 3 and a positive 2, which gives us negative 3x and positive 2, which does give us our middle term of negative x. Okay, now we have negative x cubed set equal to 0, x minus 3 set equal to 0, x plus 2 set equal to 0, and when you solve each of these, we'll get 0, 3, and negative 2 as solutions. So these are our x-intercepts. So 0, which is there, negative 2, we'll put that there, and 3, we'll put that there. Now the end behavior. The end behavior will be based on the first term, which is negative x to the fifth. Negative coefficient and a odd exponent means that we're going to have the left side, so the right side going down and the right side going up. Now I'm going to use my multiplicities in order to go through my graphs, starting from left to right. So starting from this side, I'm headed toward negative 2. Negative 2 had a multiplicity of 1 because its factor had a power of 1. So we're going to go straight through. Now we're heading towards 0. 0 here had a power of 3, so that's a multiplicity of 3. So it will go through, but it will go flat for a second and then continue. So it's going to go flat and then continue. It did go through. And now I'm headed toward 3. The power from of the factor that 3 came from is also 1, so it will go straight through. The multiplicity being 1 there. And this is our final graph. Number 7. We're going to graph this polynomial. And let's put the graph out here. Okay, first, finding the y-intercepts. We find the y-intercepts by taking the function and setting all the x's to 0. This will give us 1 to the third power, which is 1, 3 to the second power, which is 9, and 5. So 0.45 is the y-intercept. Okay. Next, we want our x-intercepts. So we're going to set all of these, the entire function, equal to 0. Okay, and then we're going to solve for x. So we have 1 minus x set equal to 0, 3 minus x set equal to 0, and 5 minus x set equal to 0. When this is solved, x is 1 here, x is 3, and here x is 5. So these are our x-intercepts. 1, 3, and 5. Next, we need our end behavior. The end behavior will be based on the first or the leading term. So I'm going to write out my factors, or expand my factors. That's 5 minus x. Okay, and then I'm going to use a FOIL, just the first part of FOIL. We're going to multiply the negative x times negative x times negative x times negative x times negative x. Okay. When we multiply all those negative x's together, which will give us our leading term, we will have negative x to the, positive x to the 6th power. 1, 2, 3, 4, 5, 6. So that'll be positive x to the 6th power. This suggests that my end behavior will be both sides will be going up. So this side will be going up, and this side will be going up. Alright, now, using multiplicities, let's work through. Okay, first I'm going to go through my intercept right here and head toward 1. The multiplicity for 1 right here is a 3. So it's going to be an S-curve, or it's going to go flat for just a second and then come out. So let's see if I can go flat on there. There we go. And then head toward 3. No, it doesn't look quite flat, but that's good enough. All right, now for 3, the multiplicity is 2. Multiplicity 2's bounce. So we're going to bounce right there and not go through. There we go. All right. And now I'm headed toward intercept 5. Intercept 5, the multiplicity is 1 because the power on the factor is 1. Understood 1. So I'm going to go straight through. And that finishes my graph.